This is Neri, which is awesome. It's the best. I'm serious. You can see, I'll show you how it works. You can like, oh wait, can you? Where'd the other one go? Oh, there. You can like switch. Anyways, okay. Thanks for your patience. Okay, I'm just getting set up here. Polyphonotopes is like this project I've been working on for almost 15 years. And it's really exciting to share it like publicly for the first time. And I'll just give you like a teaser of what's ahead just so you have some intrigue. But to do that, I'm using Bitwig over here, and I have this plugin that I made that I will share. Can you see? Yes. Okay. So this is sort of kind of the original, the Polyphonotopes concept is like, you can see the red nodes are the circle of fifths. Okay, so if I play, like, I'm gonna turn it up a little bit. If I play like, this is an F Lydian scale, you can see it right there. If I play just one note, these are all of the scales that have that one note in this graph. Right now, the yellow ones are the altered scales. If I play some combination of notes, like between 1 and 7 notes, then you can see all the scales that have this shape, right? This one, maybe you can hear it, and you know what these notes are. That's the pentatonic scale. You can see that there's 3 red nodes. The red nodes are the diatonic scales, and 1 yellow node. The yellow node is the altered scale. And what you can see there with the connections is that, so let me demonstrate how if I add 2 more notes to the pentatonic scale, that's 7 notes, right? If I add 2 different notes, I'll move one of them over. Then you can see another diatonic major scale. I move it over. Here's another one, and then I'll go to the altered. So this is like a way of sort of like looking at maybe what we experience through sound, but visually. It's a representation. Okay, so that's the sneak preview. And then I'm learning how to use the computer. Oh goodness. Sometimes it gets stuck. And then I can't. There we go. Okay. Actually, I'm going to take this. So I had a hard time narrowing it down, so I have a bunch of crap in here to look at. But polyphonotopes, like, what is it? It's like, many sounds, shape, space, something. And I think of it as like a toolkit for like articulating harmonic spaces and relationships in harmonic spaces. And my motivation was to learn how to play music like more in a more embodied way, instead of just like having all these theory concepts in my head and having no clue what they actually meant versus my intuition about how to play music. So I'm thinking of it as like a way to develop like harmonic spatial awareness, and not just in the abstract sense, but also in terms of like how different harmonic relationships, how when we play music we share the harmonic space. So spatial awareness harmonically means like being aware of like when you play some notes, then are you taking up more or less space in the shared space. And then, just like developing some fluency. I have aphantasia, so I can't visualize stuff naturally, so the computer is awesome. Okay, so that's Polyphonotopes. I've been working on it since 2013. Um, let's see. I showed you basically this concept of musical shape spaces, which is like evolving to be more than what I showed. But like the circle of fifths is just one path through like a much larger space. You could add like other scales as well, right? And I'm going to get to that. Let's see. The map is not the territory. Like, I love that expression, but like maps and the actual experience of being in a place, they feed back on each other like all the time. So the representations that we use affect how we experience like space. And yeah, music theory scares people away. Like, I love music theory, but when I try to play music with people and speak in music theory language, some people are like, nope, I'm not doing that, you know. So how can we sort of, I wish that there was like language, like music language, like theoretical language that resonated more easily with people, with where people are at in playing music. Yeah, like musicians, a lot of musicians know like super profound music theory, right? But they don't know the language for it. Okay, so like that's frustrating because it makes it hard to communicate. I mean, sometimes the best way to communicate is just to play. So yes, that brings me to the next point. Yeah, I'm not gonna read all that stuff. Like, so like playing music, like there's a schism in my mind between like well, actually there was some good stuff in here. Like, where was the one? Oh, I don't know where it is. But like, you know, you play Monopoly. I don't really like Monopoly, right? Or you play Tetris. I like Tetris. You don't hate the player, hate the game. Like, there's different ideas of play and like ways that we experience like playing music, and a lot of times music specifically gets wrapped up in performance rather than like presence, you know. And getting a little deeper into the idea of play, like think about games from a mathematical sense. Like, a game is a set of rules and constraints that we agree to share, right? So when we enter into the space of playing a game, we have some constraints that we have agreed to submit to, and then we have freedom in that we can explore that space together. So that's kind of like the approach I want to get to. And I'm rambling now, so let me open the other window because I want to invite y'all to scan a QR code. And we can all try out walkie-songy, which is like a walkie-talkie of song. If you would like to join, please scan this QR code. And remember, we were all going to be sharing the harmonic space. So, and I'll start it off. Let me just make sure everything's working. Has everyone scanned the QR code? I'm going to wait. Just if I'm going to close this thing, but if you want, you can type in jubilant-dream-crystal. That was random, but I liked it. Okay. Is it not working? Maybe it's... This is experimental. Okay, hold on, just... Oh, good. Okay, so I'm actually not connected to the right one. So that's, oh wait, am I? What's going on? So some people see the avocado and the peanut, but I don't. What's going on? Bugs. Okay, I've never tried this with however many people there are in here. Let me just try to turn it off and back on. So what's going on behind the scenes is I have this this VST plugin that connects with peer-to-peer software, and it's supposed to be showing something. Okay, I might have to punt this demo. I'll try reloading one more time. Well, there's a lot of peers. And can you raise your hand if you see something on yours? What? You guys all see it? That's not fair. Okay. Maybe it should work fine, but you can all, I imagine you've all been seeing each other's emojis that you dragged onto the thing. That's so awesome. Well, I wish that the music was coming my way. Yeah, let me try. I'll make another room. Good idea. What? Oh my goodness. Okay, everyone's doing splats, and maybe the reason there's no sound is because there's too many. Oh. Okay, what I'm going to do now is what everyone. Okay, so could y'all help me clean this up? You drag the emoji into the middle, a hole will appear. You drop it into the hole, and then that was super quick. Okay. So. Oh. Wow. Okay. Now, this is an experiment. Oh. Oh, you know what it is? I muted all the things. Yes. Okay. So these are just the tones that are on here. Now, oh, that's dissonance. So yeah. So what we can do is, whoa, yeah, people are. All right. So remember, we're sharing the harmonic space here. So one thing we could try, if you want to make it sound like kind of less dissonant, would be to just focus on those black keys, like just the black keys. And I mean, I could totally go in there and actually I could just. Oh, that's kind of nice. So another thing you can do is you can drag the emoji pieces around, you can move them like from one note to another. And I'm going to start adding some more sounds, and y'all can just play the music. This is getting pretty distant back there. I think maybe there's a glitch where... Oh, no. No, that's not bad. There's some extra notes that I don't know where they're coming from that are not on here. So I think, yeah, it's overloaded right now. Too many CRDT updates. Or, oh no, actually, you know what it is? Let's toggle off. All right, I'm going to engage. Sorry for the Okay, now if you scroll down, you can see a little hint. Is it empty for everyone else, or? Okay, I'm gonna have to work on the bugs. So I'm going to start a channel from scratch, and sorry everyone, I'm abandoning Jubilant Dream Crystal, and and I'm going to just show a couple. Thank you, by the way, for participating in that. That was awesome. So this next one is called. I'm so disoriented with the screens. This next one is called Noble Birch Marsh. Okay, and if you join, please be mindful that we're sharing this space, because I just want to show some of the functionality of the harmonic stuff. So, is it going to go? It's not going to go. Well, that's too bad. Yeah. I might just since it's not working how I hoped, I might just shift gears and explore the graph again. But yeah, there's a whole, we can talk about it another time. Feel free to chat with me after, but there's a lot of richness in thinking about the how open and closed certain shapes are. If you have one note, that single note is open to many pitch classes. If you have lots of notes, it's more constrained. And anyways, okay, so. I'm getting so many glitches right now. Okay. So what I want to show is that. Okay, never mind. It crashed. Yeah, something crashed. A bunch of things. Well, you know what? Here's another idea. Oh, there it is. Yeah, you can ask a question. It's what? Yeah, it's a serialization of YJS or YRS CRDTs. So there's these updates that they're supposed to sync really cleanly, and maybe they don't. Oh, something is happening. There's not hardly any memory being used. Now, which one is this the Noble Birch Marsh playing right now? Okay, keep it sparse. This is what I was wanting to do earlier. So, if you scroll down, you should be able to see in the Noble Birch Marsh space the pitch class sets that are compatible with the current notes. So that could be diatonic scale, that could be a pentatonic scale, that could be a triad, whatever. And actually. So what I'm gonna do now, I'm gonna change the bass. Oh no, it's getting dissonant again. Okay. Okay, that's good. Some people can see it because they joined the channel. Oh yeah, I think this is it. Okay, so this right here. Okay, this is great. So now we can see. All right. If we constrain just to the pentatonic notes, say, I'm making executive decisions right now. Somebody's, I don't know, it's either somebody's changing it or the updates are slow. But right here, you can see, these are the compatible okay, so when for the, I'm gonna just stop the music. Stop the music. Okay. You guys like the music? I'll just turn it down a little bit. Are we on? Is this the same as that? It is. Okay. Yeah. There's bugs. There's tons of bugs. Oh, perfect. Okay, so like down here, what you can see is there. Perfect. So this is a pentatonic scale. You can also see, this is what I wanted to show, and then I'm gonna like wrap it up. This is a concept from recently called possibly solfege, okay? What I've been doing is using solfege notation to talk about modes, because like these Greek names are very long and unwieldy. If you just say like fa, that's Lydian. If the root is fa, then it's Lydian. So what this is saying is like the bass note right here is this one, the shell, okay? What this is saying is that given these notes up here, the shell could be do, re, or so. So these are the possible solfege roles that the shell could be playing right now. The splatter on B flat could be la, mi, or ti, given these notes, because we have a less constrained group of notes right now. If I drop the peanut in the hole, it's not going down there. Okay. Like, just if there were less notes on the keyboard, then we would have more solfege possibilities, and I'll demonstrate that with a clean one that nobody knows about how to get to. Okay. Not even me. Okay. If anyone thinks of alternative names to Waki-Songi, let me know. Okay, so I know you guys can see it, but don't join. Okay. Okay, so look at all these possible pitch class sets, and this is just the ones that I put in the filter. Like, there's way more than that, but you know, as I constrain, there are fewer and fewer, and if we get to 7 notes, then there's just one, and it's G major, with where the D flat is so, and the high note is fa apparently. So yeah, I'm gonna just. Oh yeah, question. Oh, the enigmatic scale is like. I'll show you on here actually. The enigmatic scale, it just is like this crazy scale with 3 half steps in a row. Let me see if I can find it. If I add, oops. Wait, actually, it's an altered scale with, hold up. It's kind of hard to use the circular keyboard. D enigmatic, okay, D. This is D. So that means that it would be, oops. There. 4 half steps, wait, 1, 2, 3 half steps in a row. That's the enigmatic scale. And you can look it up online. But, okay. How am I doing on time? Like 5 minutes? Okay, 5 more minutes. I'm just going to zoom through some of the slides. All right, so yeah, this idea, like music is a spiritual thing, you know, it's not just mental or physical. It's like it's a shared experience. That's what I mean by spiritual. Like it's a collective experience, and we can use these kind of tools to like learn possibilities. But then like when people play, usually it's like we listen to each other. Okay, that's my little pitch. Oh, math. I love math and I love graphs. Okay, what's important? Oh, XOR is crazy. I used XOR to do the accidentals as like a little trick. I was like, oh, you can swap 2 accidentals by doing an XOR. Like say you want to move F to F sharp on a diatonic, on a C major scale, you want to move F to F sharp. You can do XOR of C major with F sharp. It'll flip the F to the F sharp, and you apply it again, it'll flip it back. But I realized that recently that you can use XORs of symmetric pitch class sets with like chunks, like chains of chromatic pitch classes, and it will like swap into, like it will take the whole tone scale to the pentatonic, or the whole tone scale to the diatonic, or the stack of minor thirds to the diminished scale, and like all these crazy things. So it's kind of similar to doing an accidental, like on the circle of fifths, you do little accidentals, but it feels like more broad. So I'm exploring that, and I started writing a lean library combined with a bunch of data log specs, shapes. Okay, we talked about this. Yes, walkie-songy. Oh, this is super important. My niece came to me, she was like, Uncle Micah, when are you going to teach me piano? And remember, it's every week. And I was like, okay. So we've been working on piano lessons for a year and a half, and I've been using this. I have a map that we use, and we put like her favorite pop songs onto the map, which is like this graph, and she's starting to get it, and it's like really exciting because, you know, she's somebody who you can't really tell her what to do, and the fact that that this is working for her is very exciting for me because, yeah, I think it could be useful to a lot of people of all ages, and I want to do a lean formalization. Zen Harmonic is like the community of like, you know, non-12 tone tuning stuff. I want to get into what they're up to. I haven't gotten into that yet. I want to make like games and puzzles and educational tools, and then I also want to explore the idea that like harmony and rhythm are kind of like just slow and fast, or fast and slow versions of the same thing, and see like what this would do for rhythm. And then also Clifford algebras have like like sort of something similar to XOR, so I want to mess with like continuous versions of this, and then also using category theory to kind of like make it like more interoperable, like pluggable with other ways of representing stuff. And oh, yep, okay, that's all. I'm done. Thank you. And we can talk. Oh yeah. If there's time, you got time? Okay, yeah, totally. Yeah, I think so. I mean, in some sense, that tool kind of already lets you do stuff like that, but I want to extend it more to play with those kinds of things. Yeah. Yeah. I was I grew up like with like a lot of like jazz and gospel music, and there's a lot of altered scales, but I never really understood like why, like what's the relationship. So when I first started working on this, I was trying to figure out like what's the relationship between the altered scale and the like the major diatonic scale, and it blew my mind that just like there's two major scales connected to each major scale, that each major scale also has two altered scales connected to it by a single accidental. So like, if you take C major scale, you do like C sharp, there's altered scale. If you do E flat, there's altered scale. So yeah, that was sort of like the first like little like thing that was like, aha, what? This is crazy. Like nobody ever told me about this. Yeah. They're not very complicated properties. It's kind of just like little things about the relationship between the 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 symmetries involved, like the note being off and on, and like there being 12 notes. So like, and then there's like different transformations you can have, and like finding correspondences between like, say, when you translate, it's the same as doing an XOR with this sort of thing, and to basically making maps and using those then to generate. I want to use the lean to formally verify the generated like data log things that I will use to parse like syntax into like a representation of like of sequences of like pitch class sets and stuff like that. Yeah, not yet, but let's talk about it. Yeah, I've glanced at some of those things, and I don't always understand. I think there's the way I'm thinking of it is like there's many representations, and a lot of them probably point to similar patterns. And so I'm curious to understand better like where this fits. I know, like for example, I don't understand John Coltrane's like circle wheel. I really want to. I don't get it yet. But one thing that I did notice that was cool is that yeah, I have a alternative version of these graphs where you map like multiple hops, like So you map like the 2-hop graph would be like all the scales that are connected by 2, and then the 3-hop is all the scales connected by 3. If you go to the 4-hop graph, you can see the Coltrane changes in there. But also when you add altered scales, it forms like a hexatope, where it's like you have the Coltrane scales, like giant steps and stuff, but then connected to altered scales. It's crazy. And like when I've made music out of it, it sounds cool. And so, yeah, I think there's a lot of connections, waiting to be found. And yeah, the lean stuff hopefully will help with that as well. Thanks, everybody.